Hi everybody, I'm really excited to start chapter 1 with you, and chapter 1 does a really good job of giving you an overview of the basic skills that we're going to be using all year. Really foundational stuff. So let's go ahead and jump in. These are the goals. These are what you're going to be able to do. You'll notice at the beginning of each section, there's going to be a list of these. So you could use these as a quick reference for when you're studying and like, oh, I forget what distribution means. You could look back at the beginning slides to quickly see which section has what skills in it. All right, what is the study of statistics in general? So you could sum up statistics by saying it's the science of data. It's numbers with a context is another way to describe it. You could break it up into four major ideas. There's data analysis, which is what we're going to look at first. There's data collection, which is all about setting up well-designed surveys and experiments. There's probability, and then there's inference, which is the really, I would say, culminating part of statistics. We take everything we've learned in the previous chapters and apply it all together. All right, so at its heart, the idea behind statistics is often that there's this population, there's this large group of things that we want to know stuff about, but it's not possible to gather data on all the things, so we take a sample. So a quick example of this, we want to know, we want to predict who people are going to vote for in the next election, and there's no way we can ask every person, either in Washington State or the U.S. as a whole, who they would vote for. So instead, a lot of the polls that you see done take a sample instead and then do some inference to learn about the population as a whole from that. The very first thing that we're going to learn specifically is the idea of a variable. So this word means something different in stats than it does in other math classes that you've gotten used to. So a variable is any characteristic of an individual or object. And we can split up variables into two major categories, the categorical variable and the quantitative variable. So the categorical variable is anything that's an adjective, things like, favorite color, favorite ice cream flavor, what gender you are, what type of car you drive, things that could be thought of as an adjective, and it's rarely ever a number. And in fact, even if it is a number, a lot of times it's more a descriptor of something that's not given a numerical value. So, for example, zip code. It doesn't describe a value of where you live, it just describes more of a location. Compare that to quantitative variables. Quantitative variables are always a number, and you could think about it as having units. These are things that are measured. We could put quantitative variables in order from least to greatest. So height, weight, average GPA, average amount of time it takes you to get to school, all that sort of stuff is quantitative. It doesn't make sense, for example, to put categorical variables in order from least to greatest because they're not numbers like quantitative variables are. A distribution, it describes what values a variable takes and how often it takes those values. Most of the time in stats, you're going to see some sort of graph and you're going to be asked to describe the distribution. We'll get into the details of that in the next section, but for now, just know that the distribution, you could look at stuff like the shape, Are there outliers? How spread out is the data? What's the average or what's the median? We're describing things about the data at that point. All right, I want you to pause the video and I want you to try answering these 3 quick questions about this data. All right, so who are the individuals in this data set? The individuals in this data set are the 10 randomly selected U.S. residents from a recent census. What were the variables measured? So the variables measured were these up top: the state, number of family members, age, gender, marital status, total income, and total time to work. Identify each as categorical or quantitative. So state is categorical, number of family members is quantitative, age is quantitative, gender is categorical, married status is categorical, total income is quantitative, time to work is quantitative. Describe the individual in the highlighted row. So this individual is from Virginia with 4 family members, age 22, male, single, total income of $3,000 per year, and travel time to work is 0. So this is probably a guy that lives at home with his parents, but making some sort of statement like that is an inference that is not explicitly given to us. So it would be incorrect to describe this person as somebody that lives at home, even though we could infer that. Maybe some further investigation could answer that question for us. All right, let's look at some more data. Here is some information about the passengers and the crew aboard the Titanic. Now this is, I guess, sort of interesting, but we can make numbers like this come alive when we present it either in a table or a graph. All right, so let's talk about tables first. A frequency table, like this first one, is a way of organizing the counts of something. So if you ever asked about a frequency table, know that that means that it is the raw count of whatever you're talking about. Whereas a relative frequency table has to do with percentages. And you should be pretty fluent about which one means which. I should be able to say relative frequency table, and you should think percentage table. So if we look at the 2 tables here, you can see I've organized the data from the last slide into both. So we've got our variable of class. I've got the values of both the counts and the percents. Now, specifically talking about categorical data, there's a couple different ways we could display it, and you've probably encountered these quite a bit in your life already. So bar graphs are one way. It displays the distribution of a categorical variable, showing the count or percent, right? You can do either one. And it has to follow something called the area principle. So the area principle says that the area occupied by a part of the graph should correspond to the magnitude of the value it represents. So here's an example of what I mean. If you use rectangles, most bar graphs use rectangles. They should be the same width so that only the height determines the area. For example, this would be a pretty poor bar graph if we had, what's your favorite color, and green was this bar. A good example of a bar graph would have roughly the same width for the next value. A poor example would say, or would show something like this. This breaks the area principle. So make sure that the only difference in whatever it is that you choose for a bar graph, normally a rectangle, the only difference should be the height. The horizontal axis should include the variable by name and the possible categories. These are what I call easy points. Don't miss the easy points of labeling an axis clearly, for example. Make sure you space the bars well, it's consistent, and or on the vertical axis where you're giving either frequency or relative frequency, always start at 0. Otherwise, the graph can be misleading. If you have something that you're trying to compare, right, favorite, or let's say average height between men and women, it's a pretty common one. Make sure, or if you don't have similar sample sizes, it makes more sense to use relative frequency, just because it's easier to compare percentages directly when you don't have the same total between two things. All right. So here's a really good example of a bar graph for the data that we've seen already. Notice I've got my well-labeled values. I'm starting at 0, and there's this consistent spacing between each bar, and the width of the bars is identical. The only difference is their height, so it quickly helps me be able to see, there were way more crew and third class members than first and second class. Pie charts are another good way to display categorical data. They're especially useful when you want to display data as part of a whole. The circle itself, or the pie, represents 100%, and you slice it up according to how much percent a variable's value takes up. The only way this works is if the categories don't overlap, just because there's the sharp division between each one. Again, make sure you label well. You could use different colors. This is a decent one. I would say this would be even better if you added percentages to each slice so you knew exactly how much of the category you were dealing with. This one does a better job of that. Tables, I would say, are often more boring than graphs. You can usually see and compare things way more quickly, and often in a prettier way if you use graphs. Again, just to repeat, the area principle is very important. Here's another actual ad. A lot of the stuff that you're going to learn in stats, speaking of ads, show up in marketing in ways that are manipulative. And if you know that, you're going to be better armed at being able to resist advertising tactics and manipulation by general media stuff, trying to sway your opinion in a way that's a little bit shady. So for example, the idea of this, right, is that, oh, look, DirecTV has 95 channels, but the Dish Network only goes this high because it only has 81, cable only has 56. But they're obviously trying to give you an ad for DirecTV. The area of this is way bigger than this, even though there's not a whole lot of difference between them, because they're trying to trick your brain into feeling like DirecTV's bigger and more worthy of spending money on. Also, there's no y-axis. Where are the values? Can't start at 0 if you don't even have an axis. Which is why, your brain's going to think, okay, this distance is 56, but this distance is 25, and this distance is 14. It's not consistent. It's very manipulative. This is your homework. Don't forget, when I give a list of numbers like this, I mean the odds, the odds only. So this would be 11, 13, and 15. And then whenever I give even numbers like this, I will always give you the answers so that you can check.